In the second part of Mod 1b, we are going to be working with polynomials. Remember that polynomials are expressions that consist of terms which are including both variables and constants. We are going to be looking at doing operations, adding, subtracting, multiplying polynomials. On example 4, we are asked to simplify the expression that we are given. And on A, we are given two polynomials that are being added together. When you have a plus sign outside a set of parentheses, there is no effect on the items that are within the parentheses. So we could rewrite this entire expression without parentheses by saying negative 2w squared plus 4w minus 1 plus 6w squared plus 7w plus 5. Remember that in order to add polynomial expressions, you combine the like terms. Like terms have to have the same variable with the same exponent on it. So, negative 2w squared and positive 6w squared are like terms. Adding those, we're going to get positive 4w squared. We have a positive 4w and a positive 7w. Adding those, we're going to get plus 11w. And then for constants or plain numbers, we have negative 1 and plus 5. Negative 1 plus 5 gives me plus 4. This is now the simplified version of the original expression. On example B, we have two polynomials that are being subtracted. When you are subtracting that second polynomial, you have to subtract each term in the polynomial or distribute that negative sign. So the effect is that each of the items in the second polynomial will change signs. So this will become 3w squared plus 2w plus 4. The first polynomial does not change. The second one becomes minus 6w squared minus 5w plus 9 when we distribute that negative sign to each term. Now we're going to find our like terms and put them together. 3w squared and negative 6w squared gives me negative 3w squared. Positive 2w, negative 5w gives me negative 3w. Positive 4, positive 9 gives me positive 13. On example 5, we're going to use the distributive property to remove the parentheses in the expressions that we are given. Remember that the distributive property means that you take the item that is outside and multiply it by all of the items that are inside. So 7y to the third times 10y will be 70y to the fourth. 7y to the third times positive 4y to the ninth will be positive 28y. Add your exponents, 3 plus 9 is 12. What's different about B is that the item that we need to distribute is on the end instead of in the front. The process does not change. We still have to take that item that's outside the parentheses times each of the items that's inside the parentheses. So if we take 9z to the fifth times 2z squared, 9 times 2 gives us 18. Add our powers, we get z to the seventh. Negative 5z times positive 2z squared, we're going to get negative 5 times 2 is 10. Add your powers, z to the third. 8 times 2z squared is going to be positive 16z squared. For C, we need to take negative 8v to the sixth times each of the items that are inside the parentheses. So for the first one, negative 8v to the 6th times positive 6v squared is going to be negative 8 times 6 is 48. Add the powers. 6 plus 2 gives me v to the 8th. Negative 8v to the 6th times positive 9v. We're going to get negative 8 times 9 is 72. Add your powers. 6 plus 1 gives us 7. Negative 8v to the 6th times negative 8 gives us positive 64v to the 6th. What's different about D is that we have two variables that appear in this problem. So remember that when you are multiplying, when you want to add the powers, you only add powers for the variables that match. We still have to do the idea of taking the negative 4b to c to the 6th outside times each of the items inside. Negative 4 times the positive 3 will give us negative 12. B to the first times b squared will give us b to the third. The c to the 6th that's on the outside we carry along as it is. For the second term, negative 4 times negative 7 gives us positive 28. B to the first times b to the 5th, add 1 plus 5, you get b to the 6th. C to the 6th times c to the 3rd, add 6 and 3, you get c to the 9th. For the third term, negative 4 times 5 gives us negative 20. There is no b, so we're going to carry through the one that's on the outside, and then take the c to the 6th, add the 3 from the c to the 3rd, we get c to the 9th. When you multiply two polynomials, each term of the first polynomial must be multiplied by each term of the second polynomial. When we have two polynomials that are each two terms, we use what is commonly called FOIL. F means first term times first term. The O stands for outside term times outside term. I stands for inside term times inside term. And L is last term times last term. So on example 6, we're going to start multiplying. And we're going to look at the two terms of x plus 4 times the two terms of x minus 6. Your first times your first means you're taking the x times the x. X times x is x squared. The outsides are the first term and the last term. X times negative 6 is negative 6x. The insides are the two terms in the middle. If we take 4 times x, we get positive 4x. And then the lasts are the second of each one. Positive 4 times negative 6 gives us negative 24. Now, combine any like terms, and if you look, we have two terms that are like terms in the middle. We will get x squared. Negative 6x plus 4x gives us negative 2x minus 24. On example B, we are still doing the same idea. We're going to do FOIL. So our first times our first is going to give us 14. The outsides are going to give us negative 10y. The insides will give us positive 35y. And the last times the last will give us negative 25y squared. We have like terms of negative 10y and positive 35y. So combine those like terms. Negative 10 plus 35 gives me positive 25y minus 25y squared. On C, if we take our first times our first, we will get 6 x squared. Our outsides will give us negative 21x. Our insides give us positive 2x. Our lasts give us negative 7. Combine the like terms, you will have 6x squared minus 19x minus 7. For D, take your first times your first. 2x times x gives us 2x squared. Outsides, the 2 times the negative 6 gives us negative 12. Take the x times the y, you get xy. Insides, positive 3 times 1 gives us plus 3. X times y is xy. Last times last, positive 3 times negative 6 is negative 18. Y times y is y squared. You do have like terms in the middle. So we have 2x squared, negative 12xy plus 3xy is going to be negative 9xy minus 18y squared. Even though it may not look like it right away, when you see a problem like E that has w minus 4, the whole quantity being squared, this is still a FOIL problem. You have to recognize that w minus 4, the whole quantity squared, is the same thing as saying w minus 4 times itself, w minus 4. This is FOIL. So, if we do the first times the first, we get w squared. The outside minus 4w. The inside minus 4w. Last times last plus 16. We have like terms in the middle, so our final answer is w squared minus 8w plus 16. On a problem like F, we are taking 2 terms times 3 terms, and we don't have an official name for the process, but the idea stays the same as it did for FOIL. You must take the first term of the first polynomial times each term of the second polynomial. Then you also have to take the second term of the first polynomial times each term of the second polynomial. If we start working this, 7v times 4v squared will be 28v to the third. 7v times negative 3v will be negative 21v squared. 7v times positive 5 will be positive 35v. Now I'm going to start working on the negative 3 times everything. And to help me out a little bit, I'm going to line up the like terms underneath each other so that when we're adding, it'll be easier to see them. Negative 3 times 4v squared is negative 12v squared. Negative 3 times negative 3v gives me positive 9v. Negative 3 times positive 5 gives me negative 15. Now, to finish them up, I'm going to combine my like terms. 28v cubed does not have a like term. Negative 21v squared and negative 12v squared will be negative 33v squared. Positive 35v and positive 9v will be positive 44v, and then we have our negative 15 to finish it out. Example G is much like example F. We have to take each term of the first polynomial, which is a binomial. We're going to take 6w times each of the 3 terms of the second polynomial. Then we're going to take negative 4y, the second term of the first polynomial, times all 3 terms of the second polynomial. So to get started on that, 6w times 3w will be 18w squared. 6w times negative 4y will be negative 24wy. 6w times negative 7 is negative 42w. Now moving to the second term. Take negative 4y times positive 3w. That will be negative 12wy. I'm going to line up under its like term, like I did on the previous example. Negative 4y times negative 4y will be positive 16y squared, and then negative 4y times negative 7 will be positive 28. We only have one set of like terms. So 18w squared stays as it is. Our like terms, negative 24wy minus 12wy will be negative 36wy minus 42w plus 16y squared plus 28.